This video gives an introduction to the use of 5D Plan, the visionary software to design a production facility with a clean room, process tools, and process utility systems. We will show how to install the software, create a library, create a design and use reports and tools to review details of the design. The latest software can be downloaded from our website www.crystal5d.com. Press the download button. Follow the 4 steps in the instruction. Now you will have the software installer and a sample file. It is essential that you run the installer the first time as administrator for registration purposes. Right-click the installer and choose Run as Administrator. The installer will prepare the installation. Read the welcome screen carefully. Then press the Next button. Select the installation folder. Then press the Next button. Complete the customer information sheet with the name and organization as used in your license. Press the Next button. Confirm to start the installation by pressing the Next button. Now the installation will start. Press the Close button to finalize the installation. Now unpack the sample file with a common program such as WinZip. Also download the file project.zip via the link given in the email and unpack it. This file contains the empty building model of the sample file. Now that the preparations are completed, open the 5D Plan software. Go to the Windows Start button and choose All Apps. From the 5D Vision tab, choose 5D Plan. The 5D Plan window will open. Open Windows Explorer and select the project.5dp file. Drag the file to the 5D Plan window to open the file. The Startup View Boxes window will open. To optimize the performance, each project is divided into view boxes. Only the objects in a selected view box are loaded in memory. When opening a project, the view boxes loaded at the start can be selected. The view boxes loaded depends on the complexity of the project and your computer configuration. After some time, the project is loaded and you are placed in the middle of the first view box. The next step is to add an object to the library so it can be used in the design. A vast number of library objects is available through the 5D portal www.5dportal.com. Choose R3.3. The objects are organized in categories. These are listed in the left pane. The object groups part of the selected category are listed in the right pane, provide with a thumbnail. Select a category in the left pane, CDA. The CDA subcategory page will open. Select the desired subcategory, compressors. In the right pane, the possible suppliers are listed. Choose the desired supplier, Ingersoll Rand. The objects available are listed in the right pane. Before able to download, one needs to log in. Register with Crystal 5D Technologies 5D portal if necessary. Press the download button to download the object. The next step is to import the downloaded 5D file in the project. Select Library Editor from the 5D menu in the lower left corner. Select Library Import 5D Object. Select the database to which the imported object shall be added from the pull-down menu. Each building is divided into 5 databases for exterior, interior, EXIN, systems, and blocks of systems. Select the object to be imported from the file browser. Press the Select All button. Press the OK button. A message will be shown when the import is complete. The imported object needs to be released for use in the design. From the 5D menu, choose Project Settings. Choose the Categories tab. Select the database from the pull-down menu. Right-click the category listed and choose Add Category. Enter CDA. Click the Library Objects tab. Right-click the imported object and choose Move to Category. Choose CDA. Now the compressor is listed under the category CDA. Another method to add an object to a library is by converting a geometry created in 3D Max. Go to the Library Editor. Choose Library Convert Geometry. Select the database to add the object to. Select the object from the file browser. This object contains 2 POC parts and 4 geometry parts. Right-click POC 1 and choose Use as POC. The POC geometry will open in the 5D scene. Rotate the view to see the POC geometry properly. Right-click the POC geometry and choose Define POC. Complete the applicable fields and press the OK button. From the 5D menu, choose Add to Library. Similarly, add the second POC. Right-click the first assembly part and choose Use as Object Part. Enter the names for the assembly part, or use the suggested ones. Press the OK button to confirm the names for the assembly part. Similarly, add the other assembly parts. Press the Create Object button, which becomes active after all geometries have been assigned as part, POC, or joint. The assembled object will be shown in the 5D scene. From the 5D menu, choose Add to Library. Enter the name and display name. Press the Take Snapshot button to add a thumbnail for the object. Press the OK button to add the object to the library. The object is added to the release category. Go to the project settings to release it for use in the design. You can use a library from one project in the other. In the library editor, choose Library Import 5D Library. Select the database for which the objects shall be imported. Select the project file from which the objects shall be copied. The Import 5D Library window will open. Click the End node in front of the Systems of Fab library to view the content of the library. The objects are listed per category. Check the box in front of the categories to be imported. The number of objects selected is indicated at the bottom of the window. Press the Import button. After some time, the objects are imported. Press the Yes button to save the imported objects. Similarly, import objects from any other databases. During the conversion of the building model, objects are placed in the applicable building database, being exterior or interior. Objects that belong to the XIN database, visible from outside and inside, need to be set manually, as this cannot be automated. Go inside the building using your right mouse button. Select the left door with your left mouse button. With the Control key pressed, select the other door. Double-click a selected door with the left mouse button to open the object menu. From the object menu, choose Edit, move to Subdesign. Select the XIN database. Now these doors are visible also from outside. Similarly, change the sub-design of the other doors. In the Design Editor, you can display a layout of the building floor for your navigation. From the 5D menu, choose Window Area Map. The layout of the current floor is shown. You can use the area map to move to another building and floor. Now we will install a clean room floor. To walk around, you can use your mouse. Press the right mouse button to show a small red arrow, indicating the move direction. Keep the right mouse button pressed and move it in the desired direction. Press the Shift button while moving to move upwards. Double-click the floor part to open the Object menu. In the Object menu, functions are grouped together under Create, Edit, Group, Insert, Select, Tools and View, as well as Properties. From the Object menu, choose Insert Library Object. Select the library database the object is part of. Select the Clean Room category, then Raised Floor System. Choose Pedestal 60 cm. Now we will move the pedestal to the edge of the floor part. Double-click the pedestal and choose Edit, Move Rotate, Relative from the Object menu. The Move Rotate window will open. Select the floor part as Object B. Adjust the X and Y value to move the object. Now we will copy array the inserted pedestal across the floor. To calculate the number of copies, we measure the distances across the floor. Double-click the pedestal and choose Tools, Dimension from the Object menu. Select an object on the other side of the floor as Object B. Now you can calculate the number of copies in the Y direction. Similarly, you can calculate the number of copies in the X direction. Double-click the pedestal and choose Edit, Array Copy from the Object menu. Adjust the X and Y offset and enter the required number of copies as we calculated before. Press the Preview button. The array copy function may take some time depending on your computer specifications. Meanwhile, move to the other side of the area. As there are a few copies too many, adjust the number of copies and press the preview button again. Verify that the number of copies is correct and press the OK button. Similarly, add raised floor tiles, the cleanroom walls and the cleanroom ceiling blanks and FFUs. The next step is to install a utility supply system. Double-click the floor and choose Insert, Library Object from the Object menu and select the PCW pump. The inserted object is highlighted and the manually move rotate axis is active. Press the Enter key twice to rotate the pump. Press the Tab key to change the move rotate axis and press the A key to move the pump forward. Press the Tab key again and press the Z key to move the pump in the opposite direction. Press the Escape key to end this step. Use the Edit Array Copy function to insert 3 more pumps. Press the OK button to complete this step. Now we will add the piping on the pump. Double-click the joint at the top of the pump and choose Create Connection from the Object menu. Press the A key several times until the desired length. Press the I key to insert a component. Only objects that fit to the pipe being created will be shown. Select the expansion joint. Press the A key several times again to extend the pipe. Press the I key again to insert a butterfly valve. Press the Enter key twice to rotate the valve. Press the A key several times again to extend the pipe further. Press the R key to insert a reducer. Press the A key several times to extend the pipe again. Press the T key to insert a T. Double-click the T and rotate it manually. Now we will array copy the piping to the other pumps. With the Shift key pressed, select all piping except the final one. From the Object menu, choose Array Copy to multiplicate the piping. Now move to the second pump for a better view. Double-click the joint on the pump and choose Create Connector from the Object menu. With the Shift key pressed, click the joint on the expansion joint. An orange guide indicates the suggested pipe routing. Press the V key to finalize the connection. Similarly, connect the other pumps to the copied piping. Now we will connect the T pieces. Double-click the T joint and choose Create Connection. Press Shift-click on the joint of the next T. Press the V key to finalize the connection. Similarly, connect the other Ts. On the last T, use the A key when creating a connection to extend the pipe. On the first T, press the C key to add a cap when creating a connection. Similarly, add the other piping to the pumps. Add the heat exchangers with piping. Finally, add the filters with piping. The next step is to install the distribution piping in the sub-fab and later connect this to the supply system that we just installed. As piping always needs to start at a POC or joint, we will create a POC object first. From the 5D menu, go the Library Editor. From the 5D menu, choose Library, Create Connector. Select the database. From the 5D menu, choose File, Set Geometry. All geometries in the project are listed. Enter 300 in the Filter Geometries field. Select the 300 mm geometry. The geometry is placed in the 5D scene. Change the camera for a better view. Right-click the center of the geometry and choose Define POC. Enter the desired values for the POC. From the 5D menu, choose Add to Library. Now the POC object can be used in the design. Double-click an object near the start of the main header and choose Insert POC. Select the POC object we just created. Press the Tab key to change the active axis and press the Z key several times to move the POC object. Press the Escape key to end the insertion of the POC. Double-click the POC object and choose Create Connection from the Object menu. Press the A key several times to extend the pipe. Press Shift-click on the other side of the building to extend the pipe. Now we will install a branch header. Click on the main header to insert a T for the branch header. Press Ctrl-Enter to rotate the T 45 degrees. Press the Escape key. Double-click the T joint and choose Create Connection. Use the A key to extend the pipe. Press the E key to add an elbow. Choose the 45 degrees version. Press the Enter key to rotate the elbow. Press the A key to extend the pipe further. Press Shift-click on an object on the other side of the building to extend the pipe. Go to the end of the branch header to verify the length. Press Shift-click on an object nearby to set the length. Now we will install a takeoff. Double-click the branch header and choose Insert T. Select the desired T. Press the Enter key to rotate the T. Use the A and Z key to move the T to the desired position. Press the Escape key to finalize the T insertion. Double-click the T joint and choose Create Connection. Press the I key to insert a valve. The next step will be to array copy on pipe the takeoff to the branch header. Double-click the branch header pipe and choose Properties from the Object menu. Use the length of the pipe to calculate the number of takeoffs. Select the T and takeoff valve. Double-click one of the selected objects and choose Edit, Array Copy on Pipe. Select the T as component on pipe. Select the branch header as pipe. Enter the offset and number of copies and press the Preview button. Watch for the copy direction. Go to the end of the branch header to verify the number of copies. Press the OK button to confirm the array copy on pipe. Now select the branch header and all takeoffs. Double-click a selected object and choose Group, New Group from the Object menu. Enter the name of the group and press the OK button. Creating groups allows for easy selection later on. Now we will array copy on pipe the branch header on the main header. Double-click an object on the branch header and choose Select Group. Press the OK button to select the group. Control-click the T to add it to the selection. Double-click a selected object and choose Array Copy on pipe. Create the copies on the main header similarly as we created the branch header. Press the OK button to finalize the array copy on pipe. Now we will install an utility use system. Double-click a floor tile to insert a process tool, CVD, Novellus. Move it with the Tab and A and Z key to the desired location. Press the Escape key to finalize this step. Double-click the Process tool and choose Properties. Select the POX tab. Select the PCWS POC and note the properties. Now we will add a material transition to a joint and add a reducer to match the POC on the Process tool. Double-click the joint on the takeoff valve and choose Properties. Right-click the Material Transition field and choose Edit Value. Select PVC from the drop-down menu. Close the Property window. Double-click the joint and choose Insert Reducer. Select the desired reducer and press the OK button. Press the Escape key to finalize this step. Now we will create the connection between the Process tool and the utility piping. Double-click the Process tool and choose Properties. Change to the POX tab. Right-click the PCWS POC and choose Select. Move your mouse wheel to go to the selected POC. Double-click the POC and choose Create Connection. An orange and a purple line will be shown. The purple line indicates the direct line to the software selected connection point. The orange line indicates the suggested routing for the piping. Follow the orange guide to verify the routing is correct. Note the horizontal part of the orange guide needs to be higher to prevent collision with the branch pipe. Go to the position where the orange guide bends horizontal. Press the S key to trace the pipe to the first elbow. Press the Z key several times to shorten the pipe. Press the E key to add an elbow. Press the Enter key several times to rotate the elbow. Press the U key to update the orange guide. Go to the connection point on the branch header. Now the routing is correct. Press the V key to finalize the connection. A number of reports can be created from the 5D environment. First we show the bill of materials. From the 5D menu select Reports, select. Choose the bill of materials. Select HTML as output to view it on screen. Select the group PCW. Press the Save button to save the report. Click the Yes button to open the report. The report lists the different kind of objects in the selected group. The next report is Unconnected Connectors. From the 5D menu, select Preferences. Change to the Conflicts tab. Check the box Show Disconnected Connectors. Click the Load View file at the top of the screen to update the 5D scene. Now disconnected connectors are marked with a purple plate. From the 5D menu, choose Reports, Unconnected. Select the group Group 1. The Conflicts Analysis report is shown on screen, listing the details and locations of the unconnected connectors present in the highlighted group. Double-clicking a connection in the list will move the camera to the connector. The report can be saved also by clicking one of the format icons. Press the Save button to save the file. Press Yes to open the report. The Clashes report gives an overview of clashing objects within a group. From the 5D menu, choose Reports, Clashes. Select Group 1. The report lists details of clashes. Double-clicking a clash in the report will move the camera to that clash, so you can solve the issue in the design. The Collisions report gives an overview of objects placed in restricted areas, such as maintenance spaces. From the 5D menu, choose Reports, Collisions. Select the group under Review. The report is shown on screen and the collisions are highlighted in the 5D scene. The report can be saved with the format icons, and double-clicking a conflict in the report will move the camera to the issue. The Space Utilization report gives an overview of objects within a user-specified area and the area and space they utilize. From the 5D menu, choose Reports, Space Utilization. Specify the details of one corner of the box to be reviewed. Then specify the details of the opposite corner. Now the space utilization is calculated, indicated with the term processing in the lower left corner. The time this takes depends on your computer's specifications. The selected objects are highlighted in the 5D scene. Optionally, you can add the piping to the selection by checking the Include Piping Components box. Press the OK button to create the Space Analysis report. Change to the Objects tab to view the details of the selected objects. Alternatively, the box can be defined by selecting the box in the 5D scene. Press the By 3D window button. Click in the 5D scene to define the first corner. A red box indicates the window when you move your mouse towards the second corner. Click the second corner and the space utilization will be calculated. The selected objects are highlighted in the 5D scene. Press the Snap to Grid button to adjust the box to the nearest grid. Press the OK button to create the report. Change to the Objects tab to view details of the selected objects. The 5D Control tool provides an overview of the consumption of the utilities supplied to a process tool. The consumption data are retrieved from the factory's process control system. This data retrieval is simulated in this tutorial by means of an Excel file. Double-click an object in the 5D scene and choose Tools, 5D Control from the Object menu. Select the 5D Control data file. Select the tool under Review from the left pane. The right pane will show the actual flows for each POC and mark when minimum or maximum values are exceeded. Select a POC from the list and change to the Chart tab. The chart will show the variation in flow over time. Double-click an object in the design and choose Tools 5D Schedule from the Object menu. Select the group from the list, delivery date, or installation period and press the Start Autoplay button. The realization of the selected system will unfold. Press the Stop Autoplay button or Exit button to stop the 5D schedule. With the function 5D flow, an analysis is performed on the capacity of a utility system in terms of supply and use. Double-click an object from the group to be reviewed and choose Select Group from the Object menu. Select the group PCW. Double-click a selected object and choose Tools, 5D Flow. For each takeoff, branch header, main header and site header, the total use is calculated and this is compared with the supply capacity of the utility. The time this takes depends on the complexity of the group and your computer's specifications. In solo view of the utility system, colors are used for each header and the supply system to indicate the ratio of use compared to supply. With your mouse you can move the camera to view a specific location in more detail. Also, a report is generated with separate tabs for supply and use system. Press the Shift button while moving to move upwards. Select a specific takeoff or header to view details in the right pane. Similarly, you can view the details of the use system.